So today I am here with lecture 5 chapter 2, right? In that one I am going to discuss capacitor, right? So first I am going to discuss what is capacitor, right? So capacitor, right? Suppose two conductor is kept like this. Suppose this one is one conductor, okay, and another conductor is also present here. That one is kept like this, right? Suppose you can see here two conductor, right, placed side by side, right? And suppose one is having charge minus q, other is having charge plus q, right? So all minus charge will come to this side and all plus charge will come to this side, okay? All plus charge come to this side, right? So this combination is known as capacitor, right? So you can see here two equal and oppositely charged, right? Two equal and oppositely charged conductor placed side by side is known as capacitor, right? Okay, so two equal and oppositively charged conductor placed side by side is known as conductor, okay? Two equal and oppositively charged conductor placed side by side is known as conductor, right? So this is your conductor, okay? Two oppositively charged conductor placed side by side is known as capacitor, not conductor, okay? Capacitor, okay? So next I am going to discuss some basic points related to capacitor, right? So first of all, what is capacitor, right? Capacitor is a device, right, which stores charge, okay? So first point I am going to write note. So capacitor, what is capacitor, right? So it is a device which store charge, okay? It is a device which stores charge, okay? So now next, these are the two conductor, right? These two conductor is known as capacitor plate, okay? So we can write here conductor of capacitor is known as capacitor plate, capacitor plate, right? Okay. As you see, two plate is having equal and opposite charge, right? One is having positive charge, another is having negative charge, right? So we can write in third point, two plate is having equal and oppositively charge, okay? So third point I am going to write two plate having equal and oppositively charge, okay? Next I am going to discuss charge on capacitor, right? What is the charge on capacitor, right? You can see this combination is known as capacitor, right? This is having minus q, this is having plus q. Total charge is 0, right? But charge on capacitor is charge on, right? So someone is going to ask you how much is charge on capacitor, right? So you have to say charge on capacitor is plus q, because charge on capacitor is charge on positive plate, right? So next point we can write here, charge on capacitor is charge on positive plate, right? Charge on capacitor is charge on positive plate, right? Okay, charge on capacitor is charge on positive plate, right? Next point, symbol of capacitor, right? What is the symbol of capacitor, right? Symbol, right? So capacitor is basically represented by two symbols, right? One is like this one is also represent capacitor, right? And another is two parallel line. So two parallel line is drawn like this. This is known as capacitor, right? Okay, so this way capacitor is represented, right? You know the representation of resistance is like this, right? So similarly capacitor is represented by this symbol, okay? Now fifth point, okay? Fifth point is very important point, right? With the help of fifth point we are going to define another thing, right? So just see what is the fifth point, right? Okay. So next we are going to discuss 6 point, right? So 6 point, right? What is 6 point? So charge on capacitor, right? Charge on capacitor is directly proportional to potential drop across the capacitor, right? Charge on capacitor is directly proportional to potential difference across the capacitor, right? So charge on capacitor is directly proportional, right? Proportional to, directly proportional to potential difference, right? Potential difference across the capacitor, okay, across the capacitor. Yes. Suppose this Q is charged on capacitor, right? So this charge Q will be proportional to V, where V is potential drop across the capacitor, right? Now, if I remove the proportionality constant, I have to bring a constant, right? So this constant is known as capacitance. So from here, you are going to get one formula, right? Charge on capacitor is CV, right? V is potential drop across the capacitor, right? And C is capacitance, right? So where C capacitance, okay? Where C capacitance, okay? And V is known to be potential drop across the capacitor, and Q is the charge on capacitor, okay? So now we are going to discuss some basic things about the capacitance, right? So what is capacitance? What do we mean by capacitance? All these things we are going to discuss, okay? So first point, we are going to write about the capacitor, right? Capacitance. First point, capacitance, right? Capacitance, okay? So we can say capacitance is a property of capacitor, right? So first point I am going to write, it is property of capacitor. It is property of capacitor, okay? So what kind of property capacitance is showing? Right, capacitance is basically showing how much charge capacitor will store, right? Okay, so capacitance, right? So it is property of capacitor, right? So what kind of property it is showing, right? It is basically showing how much charge capacitor store, right? That one we are able to know with the help of capacitor, right? If capacitance is more, capacitor will store more charge, right? So we can write one more point. So capacitance, it tells ability of a capacitor. It tells ability of a capacitor to store charge, right? It tells ability of capacitor to store charge, okay? It tells the ability of capacitor to store charge, okay? Fine. Now, so I derived this formula, right? Q is equal to CV, right? So from here we can write, from here you can see now, we can write Q is equal to V, where C is your capacitance, right? From here you can see C is directly proportional to Q, and so suppose someone is going to ask you, if charge on capacitor will increase, right? Then capacitor will increase or not? Capacitance will increase or not? Answer is no, because capacitance is a constant, right? Constant is not going to change, right? So it's look like C. From here you are able to see C is proportional to Q and inversely proportional to V, right? But it is not depend on these two quantities, right? Okay. So capacitance is independent of Q as well as V, right? So capacitance is only depend on the shape and size of a capacitor, okay? So next point we have to write, capacitance is independent of Q and V, right? So we can write capacitance C is independent of Q and V. So capacitance is independent of Q and V, right? So capacitance is only depend on the shape and size of a capacitor, right? So shape and size is different, so capacitance will be different, right? So next further we can write capacitance only depends on shape and size. Shape and size of capacitor, right? So these are the basic things about the capacitor, okay? Next I am going to talk about the unit of capacitor, right? So what about the unit? So I hope you retain this point, right? So unit of capacitance, okay? Unit of capacitance, right? So you know capacitance is C, right? And C is equal to V by Q by V. Yes. And for unit of Q is coulomb, right? Coulomb. And for V is volt. So unit of capacitor is known as coulomb per volt, right? So we can write coulomb per volt. This is the unit of capacitor, right? And one more unit is also, that is farad, right? Farad, right? These are the only two units of capacitor, right? So coulomb per volt and farads, right? These are the SI unit of a capacitor. Okay. Now, so somehow I discussed basic things about the capacitor, right? Now I'm going to different types of capacitor is possible. Different types of capacitor is possible on the basis of shape and size of a capacitor, right? Yeah, but first I'm going to discuss parallel plate capacitor, right? So what is that? Just see. So next I'm going to discuss parallel plate capacitor. Okay. So parallel plate capacitor, right? So this is clear from the name. Two parallel capacitor like that. Okay. So parallel plate capacitor. Parallel plate capacitor, right? So see, this is one plate, this is another plate, right? You can see both is parallel, right? So this type of capacitor is known as parallel plate capacitor, right? Okay. So right now I'm going to calculate capacitance of a parallel plate capacitor, right? Okay. Suppose this one is having charge, this plate is having charge minus Q, right? This plate is having charge plus Q, right? Okay. So see, minus Q plus Q, right? So this is a plate, right? Parallel plate. So there will be electric field here in this region. How much will be the electric field, right? This is negative charge, right? So due to negative charge, direction of electric field will be in this direction. Electric field will come in this direction, right? And this is your positive charge. That one will also create electric field. That one will also create in this direction, right? And both electric field is how much? This is sigma by. Okay. So this is your negative plate, this is your positive plate, right? So there will be electric field inside the capacitor, right? So due to negative plate, electric field will be towards this direction. Due to positive plate, electric field will be in this direction. So both electric field is same, right? Okay. So positive. How much is the value of electric field inside the capacitor? Due to negative plate, direction is in this direction, and value of capacitance, the value of electric field is how much? Minus Q electric field due to charge on negative plate, right? And that value is how much? Sigma by 2 epsilon 0. You know this formula, right? Already you calculated this one, and negative plate is also creating electric. So let us consider parallel plate capacitor having charge Q, right? Again, charge Q means charge on positive plate, right? And so negative charge on negative plate is creating this much electric field, right? And charge on positive plate is creating this much electric field, right? So now we can write electric field inside capacitor. Electric field inside capacitor, okay? Electric field inside capacitor is suppose E, right? And this is summation of these two, right? And this value is how much? Sigma by 2 epsilon 0 and plus sigma by 2 epsilon 0, right? Okay. So after adding, you are going to get sigma by epsilon 0, right? So this is electric field inside the capacitor, right? So inside the capacitor, this much electric field is present, right? Okay. So basically, I'm going to calculate capacitance of a parallel plate, right? Capacitance of a parallel plate capacitor, right? Okay. Capacitance of a parallel plate capacitor, okay? We are going to find capacitance of a parallel plate capacitor, right? And capacitance is what? Q by V, right? So what? So we have to find potential, right? So to find a potential, we have to find electric field, right? So first, that's why I am calculating electric field, and then I will calculate potential, right? Then I will calculate potential, okay? Now, so electric field is known, right? Now we can write potential drop across the capacitor, right? So potential difference, right? Potential difference across capacitor plate. Potential drop across capacitor plate, right? Suppose V is the potential drop across capacitor plate, right? And this V is basically product of E into D, right? What is D? D is the separation between capacitor, right? Okay. Yes. Now I'm going to substitute value of everything, right? Value of electric field, right? This is how much? Sigma by epsilon 0 into D. And what is the value of sigma? Sigma is surface charge density, right? And surface charge density is how much? Q by A, right? So we can write, in place of sigma, we can write Q by A epsilon 0, right, into D. Why I am writing Q by A? Because sigma is equal to Q by A, right? And now, so potential is known, right? So now we are able to calculate capacitance, right? Because potential is known, right? And charge is known, right? So next we can write capacitance of capacitor, capacitance of parallel plate, capacitance of parallel plate capacitor C, right? And this C is equal to Q by V, right? And Q is how much? Q. And V is how much? This much. Q by A epsilon 0 into D. Now you can see Q cancel, right? So after this I am writing here, okay? After this I am writing here. So now you can see from here we can write C is equal to A epsilon 0 by D. So this is your formula to calculate capacitance of a parallel plate capacitor, right? You can see here, this is area, right? And this area is area of this plate, right? This is area of this plate, right? And D is the separation between the plates, right? So you can see here capacitance is only depend on shape and size, okay? Size of capacitor, right? Because this two is basically for shape and size, no? Right? Yeah. So now new things we are going to discuss, that is parallel plate capacitor with dielectric substance, right? Parallel plate capacitor with dielectric, right? So what is dielectric? First I have to discuss that one, right? So somehow I'm going to discuss some basics about dielectric, right? And then I will discuss parallel plate capacitor with dielectric, right? So such dielectric substance, right? Dielectric substance. So what is dielectric substance, right? Dielectric substance is somehow non-metal, right? Non-metal, right? Non-metal, you know, this is not conductor of current, right? So dielectric substance is basically non-metallic substance, right? Non-metallic substance, right? So suppose here, suppose this is your dielectric substance, okay? This is your dielectric substance, right? I bring this dielectric substance in electric field, right? I bring this dielectric substance in electric field E naught, right? Already electric field is existing in this dielectric here, right? And I bring this one in electric field, right? So inside dielectric material, suppose E is electric field inside the dielectric material, right? So this value of electric field will be how much? This value of electric field will be E naught divided by K. So see here, in case of conductor, right, as I discussed in chapter 1, right, electric field inside a conductor is 0, right? But here, electric field inside the electric field inside the dielectric is how much? E naught by K. Then what is value of K, right? K is known as dielectric constant, right? For different material, value of dielectric constant will be different, right? So we can write here where K is dielectric constant, okay? K is dielectric constant, right? Okay, and this constant is basically equals to, this K is basically ratio of epsilon 0 by epsilon naught. Now you know epsilon 0 is permittivity of free space, right? And epsilon 0 is permittivity of this material, right? So you also try to remember this relation, right? K is basically ratio of permittivity of this substance to permittivity of free space, right? Okay, now one question, why electric field is becoming E naught by K, right? Why this one is happening, right? So this is happening due to some induced charge, right? Some charge is going to induce inside this one, right? How? That one we are going to discuss, right? So this is net electric field inside, right? And how much is net electric field? this much, okay? So we can write here also Enet inside the dielectric material is how much becomes E naught by K, right? Where K is dielectric constant and dielectric constant is equal to epsilon by epsilon 0, right? What is epsilon? Epsilon is permittivity of this material, this substance, right? And epsilon 0 is permittivity of free space, right? I hope these things are clear to you, right? So this is permittivity of medium, permittivity of substance. Later we can write permittivity of dielectric substance, permittivity of dielectric substance, and this is known to you, right? This is known to you, right? This is what? Permittivity of medium, permittivity of free space, permittivity of free space, right? Okay, so everything is clear to you, right? Now, why electric field is becoming E naught by K, right? So see, as I bring this dielectric in electric field, right? Okay, as I bring this dielectric in electric field, what things are going to happen? Suppose I bring this one in electric field, right? So inside this dielectric, what going to happen? You can see here. I have to draw somehow big diagram, okay? Otherwise, it's difficult to understand. Now you can see this is your dielectric material, right? So as I bring this dielectric material in electric field, right, what is going to happen? Any material is made up of positive charge as well as negative charge. Positive charge means proton, or negative charge means electron. Everything is made up of proton, electron and neutron, right? Neutron is having no charge, so there will be no effect in electric field, no charge, right? But proton will shifted towards the direction of electric field and electron will shifted towards the direction of opposite to the direction of electric field. Suppose here electric field lines is existing like this, okay? Here electric field lines is existing like this, okay? So electric field lines is existing. So what going to happen? So inside this material, something like this going to happen, right? All negative charge will shift to this side, right? And all positive charge will shift to that side, right? So for entire, so as you see, all molecule, right? All atom or molecule of atom is all molecule is going to align like this, okay? So see, this side negative charge, this side positive charge will become negative, positive, okay? Negative, positive, negative, positive, negative, positive, negative, positive, okay? Now you can see on this side some negative charge is came, right? And this surface some positive charge is came, right? See, these two is cancel each other, right? These two, this positive is cancelled by this one, right? This positive is cancelled by this negative one, this positive is cancelled by this negative one, this positive is cancelled by this negative one, right? But there will be net negative charge on this side, right? And there will be net positive charge on that side, right? So suppose due to that some charge is induced on the surface, right? On this surface negative charge is induced, right? And in this surface positive charge is induced, yes or no, right? So see, due to negative, this side surface charge density becomes, due to negative charge, surface charge sigma p, right? Similarly, surface charge density on this side it becomes plus sigma p, right? Yes or no, right? Now suppose this one is placed inside a parallel plate capacitor, right? Okay, now you can see here, suppose this is one plate, right? And this plate is having positive charge, okay? And this plate is having negative charge, right? And surface charge density on this plate, right? Surface charge density on this plate, okay? This is a plate, okay? Surface charge density on this plate is how much? Sigma, right? And surface charge density on this plate is minus sigma, okay? Now see, this electric field is due to these two charges, right? But what happened here? This charge on this surface and charge on this surface is also creating electric field, right? Now you can see this is negative, this is positive. So electric field due to charge on this surface and this surface is in which direction? In this direction, right? Because you know electric field is from positive to negative. So here negative is present, here positive is present. So electric field due to charge on the surface of dielectric is in this direction, right? And that electric field, suppose that electric field is E, right? That electric field, this electric field is due to induced charge on the surface of the dielectric, right? So see, this is your electric field due to charge on the surface of a plate, right? And this is electric field due to induced charge, right? Yes or no? Induced charge, right? And induced charge, electric field due to induced charge is in opposite direction to this electric field. Yes or no? Right? So suppose if I am going to write E net, suppose I am going to E net. E net will be how much? E net will be E naught minus E. Why I am taking minus sign? Because E net, you know, this is in this direction, but your this value is in this direction. That's why I am taking minus, right? Okay. Now E net is how much? E naught by, right? So now I am writing here E naught by, E net is what? E net is net electric field inside the dielectric, right? And this is how much? K. And E naught. E naught. How much this two surface is creating electric field? That is how much? This E naught is basically summation of, you can see here, sigma by 2 epsilon 0. This surface is creating, and this surface is also creating sigma by epsilon 0, right? Plus sigma by epsilon 0. Total value will come how much? Sigma by 2 epsilon 0, sigma by 2 epsilon 0, right? Sigma by epsilon 0, right? So E naught is, we are able to substitute here, right? And this is electric field. This one also we have to find, right? Similarly, you can see negative, positive. Again, we have to write like that. This value how much? This value is sigma p by 2 epsilon 0 plus sigma p by 2 epsilon 0, right? See now, surface charge density is how much? Sigma p, right? So this value will also come how much? Sigma by, sigma p by epsilon 0, right? Sigma p by epsilon 0, right? I hope everything is clear to you, right? Now I am going to substitute value here, right? So first I have to write like that, and then next step I will put the value, right? Everything is, this is known to you here, this is known to you here, right? Now I am going to substitute the value. I hope you written this one, okay? So you have to write like this, okay? First you write down all these things, okay? And then start writing from here, and then write this one, and at last you have to write this one, right? So after this I am going to write this side, okay? So you can see here E naught by K. E naught by K is how much? E naught is how much? Sigma by epsilon 0, right? And K will come here again, sigma by epsilon 0, right? And this value is how much? Sigma p by epsilon 0. Yes or no? Right? Now you can see here. Suppose I am going to take sigma by epsilon 0 common, right? So inside the bracket, what value I have? Sigma p by sigma. Yes or no? Right? And this side I have sigma by epsilon 0 into K. See, sigma by epsilon 0, sigma by epsilon 0 cancel, right? So what value I have? 1 by K is equal to, see, this one can be written like this, sigma minus sigma p by sigma. Yes or no? We can write like this, okay? So further we can write K is equal to sigma by sigma minus epsilon 0, right? So this is one formula to find the value of K, right? So basically this is one formula to find value of K, dielectric constant, right? And this is another way to find. So according to situation you are allowed to use different formula. So at last you have to write these things, right? So first you write down this one, right? And then you start from here and then write this part, okay? At last write this one, okay? The final expression is, your final expression is this one. Okay, so next I am going to discuss. Okay, so parallel plate capacitor with dielectric. Okay, parallel plate capacitor with dielectric. Okay, so suppose this is your one plate, this is another plate, right? And separation between parallel plate capacitor, this separation between these two plates is how much? Suppose separation is D, right? Separation between the plate is D, right? And being a dielectric material, right? This is your dielectric material, and I kept this dielectric material in between your parallel plate capacitor, right? And this dielectric material is having thickness. How much thickness they having? T. T is the thickness of dielectric material, right? Now, suppose this plate is having charge Q, right? This plate is having charge minus Q, right? And this plate is having charge plus Q, right? And area of plate is A, right? Now, electric field. What value of electric field outside the dielectric? Suppose I am going to calculate electric field here, right? This value of electric field is how much? You know, sigma by epsilon 0, right? In this region also sigma by epsilon 0, right? Okay. But what about electric field inside the dielectric material? Electric field inside the dielectric material is suppose E, right? Suppose this is outside is E. Electric field outside is E. Okay. Electric field outside is E naught, right? And this E naught is how much? This E naught is how much? Sigma by epsilon 0, right? And inside the dielectric electric field is how much? E. And this value will be how much? This value will be sigma by K epsilon 0. Yes or no? Because this dielectric is in electric field E naught, so electric field becomes inside the dielectric is E naught by K, and E naught is having value sigma by epsilon 0, right? Yes or no? Right? So this way we are able to write it. Okay, I hope everything is clear, right? Okay, so you can see here, and now you can see electric field outside the dielectric is this one, right? And electric field inside the dielectric is this much, right? So we can write here electric field outside dielectric, electric field outside dielectric is how much? E naught, right? And this E naught is how much? Sigma by epsilon 0, right? Okay. And similarly we can write electric field outside dielectric, right? Electric field inside dielectric, right? Electric field inside dielectric is E, right? And this is having how much value? E naught by K, right? And this E naught is sigma by K epsilon 0. Yes or no? We can write like this, okay? So electric field inside is known, electric field outside is known, right? Now actually we are going to calculate capacitance of capacitor, right? Capacitance means C we are going to calculate, right? Okay. And C is what? Q by V, right? Actually we are going to calculate what? Capacitance of a parallel plate capacitor with dielectric, right? So to find capacitance, charge is already known to me. This is charge on the capacitor, but we have to find V, right? So now I have calculated electric field. Now with the help of electric field we are able to calculate this V, right? So now I am going to calculate how much is the value of V, okay? And then if I am able to calculate V, then by substituting that very V in this formula we are able to get the answer, okay? So now potential drop potential difference across capacitor plate, potential drop across capacitor plate B, and this B is how much? This B is equal to E naught into D minus T plus E into T, right? How I am writing this formula? Because you know V is equal to E into D, right? So see, electrical in this region is how much? E naught, right? In electrical in this region is how much? E naught. In this region how much? E naught, right? And thickness of this total region is how much? Total thickness is D, and we are going to eliminate T thickness, right? So thickness is left, how much thickness is left? D minus T. So E naught into D minus T is the potential drop due to this region as well as this region, right? And now similarly E into T. So in this region electrical is E and thickness is T, right? So now I am going to substitute the value. E naught is known to you, right? E naught is known to you, right? This E naught is sigma by epsilon 0, right? So sigma by epsilon 0, right? And this is D minus T, and this is also sigma by epsilon 0 into K into T, right? I hope everything is clear to you, right? Now, so you can see here sigma by epsilon 0 is common, so we can take it out. Sigma by epsilon 0. So inside the bracket I have D minus T and plus T by K, right? So now I got the value of B, right? Okay. So by substituting this B in this formula, we are able to get capacitance, right? Okay. So further, I'm going to write capacitance of capacitor. Now capacitance of capacitor is C, and this is Q by V, right? Q by V, and Q and V is how much? Sigma by epsilon 0, right? Sigma by epsilon 0 D minus T plus T by K, like this, okay? Yes or no, right? And sigma by epsilon 0 is how much? Sigma by epsilon 0 is known to you, right? So Q sigma by epsilon 0, we are going to substitute the value Q by A, right? Sigma is how much? Q by A, the surface charge density, right? And inside the bracket we have D minus T plus T by K, right? This Q cancel, right? Okay. So finally we can write C is equal to A epsilon 0 D minus T plus T by K. C. This is your formula to find capacitance of the parallel plate capacitor with dielectrics, okay? Right? Where D is separation between the plate, right? T is the thickness of dielectric material, right? And K is the dielectric constant, right? So everything is clear to you, right? This one is went up now, right? This is in 1 by something now, so it will go up, okay? So finally we can write like that, okay? So this is all about today's, okay? So in next class I will try to find energy of a parallel plate capacitor, right? So that's all for today.